anyhow.
So I'm going to talk a little bit about some of the new data modeling features that we introduced in 10.2. I think Close Reach, you're going to request that we do the questions at the end of this. Is that correct?
Yes, we can do it. Actually, Jacob, that's a really good question. We can do it either way. I can monitor the chat and do them as we go, or we can save everything for the end. What's your preference?
I don't care. I'm fine digging into questions during the demo. So if that helps when questions pop up when I talk, then
sure.
All right.
So why don't we do that? If folks have questions as Jacob's going through, put them in the chat panel, and I'll interrupt him at the appropriate spot when he takes a breath.
Perfect. So I'm gonna instead of just doing PowerPoint, I'm gonna actually use the tool to do a little data modeling in here and show how we can move between the conceptual, logical, and physical layer in the data models. And again, as I do this, whatever questions you might have, just fire off, and then we'll take them as we go. The first part here is we have a new type of diagram in here called a data modeling structure. And basically, the data modeling structure is a way to kind of lay out all the different subject areas that you're going to model up or describe. So subject area typically represents something like an IT system or a system in general. But I should say before I continue, I am not a data modeler. So there's going to be very easy for you guys to ask me questions where that I will not be able to answer. So again, I'm just going to go through some of those new features in here. So if I do a new subject area in this model, it will pop up and ask me if I want to start with an empty data model. So if I say yes to this, then it'll automatically open up a new conceptual data model. So if I just close this one and go back and have a look at the subject area that I just created, you will see that it has created a conceptual data model and associated that with the subject area. Now, what I can do on these subject areas, I can double click on these, and if there are any models associated with the subject area, they will pop up in as a little pop-up menu, and when I click on them, they will be able to take me to the data model. So this is a regular type of conceptual data model. So I can do a ball and some fruit and put in regular type of relationships in here. So conceptual data modeling, there's nothing special about this, but what we can do now is you can go up through the tools menu and you can ask the system to convert your, in this case, a conceptual data model to a logical data model. So the second you do that, it'll ask if it should create relationships, and now it will automatically generate that logical data model based on your conceptual data model. And now you can go in and start to build your conceptual model. So I can do my ball ID. I can go in and assign it a data type. We can go in and if you open the key up here, the primary key for the data entity, it'll automatically ask which key to use, and then you get the key information defined for in this case, the primary key on the ball. And I can go in and I can create a description. And again, go in and define the data type. We can do that on the fruit as well. Do a fruit, fruit ID, give it an int, go up, associate the key, and we can add a description to this one here as well. Define it as a string. When I open the relationship here, and there is no key, foreign keys defined in here, so these two are empty. If I leave them empty and just close here without defining them, the system will pop up and analyze and ask you if you want to use the ball as the primary key in here. And what happens now is you'll see that in the data entity, the ball ID is now included in here as the foreign key. So now we have those defined as well. The data models, the logical data models in here, you can go in if you want. There's a show hide, so you can show all the information in here. So if you want to see both the keys and the fields in here, you can opt to show them directly on the diagram instead of having to open the objects. And now finally, I can go and convert this to the physical layer, and it'll ask me if it should generate relationships and indexes. And if I say yes to both, we will now get the physical data model in here, meaning we now have tables and indexes associated with them. So we have tables defined, and you can see the indexes defined on each of these as well. So the idea with this structure here is the ability to take your data model and have the tool help you move between the different abstraction layers in your data model. If I close these here and go back to my data model structure, when I double click on my subject area, you'll see that now I have both the conceptual, logical, and physical model in here, and whichever I click will be opened directly. So it'll handle those as well. So the idea is that this data modeling structure is where we can orchestrate all our subject areas. Now, before I move into generating DDL and reverse engineer, are there any questions on this so far?
There does not appear to be any questions in the chat at the moment.
I have a quick question. When you initially created this, did you use the data modeling structure, or did you use the conceptual data model template?
I actually used I used the data modeling structure and added the subject area in here, and there's a reason for that. If I go in here and we look at the data models here, and when we convert from one to the other, if I go in here, let me just pick up, we have different data types available in here. So when we go in on a data type, you'll see that there are different types available to define the data type. They come from my subject area. So when I have these subject areas in here, I actually have something that is called a physical implementation. And what this one in here, you can see that by default, it'll use ANSI SQL. But the type of database you might have behind the scenes will define what type of data types you will have available for those different type definitions when you do the data modeling. So that is the reason why these are linked up against a modeling structure. It's not required. there's no problem in you starting with just modeling out a conceptual data model, and you can always associate a conceptual data model with any of these subject areas from the data modeling structure. Did that make sense? Let me maybe what I'll try to do now is try to link this up against an existing database and do some reverse engineering and try to explain why we do the way we do. So let me create another subject area here. We'll call it Northwind. This time I will not create a conceptual data model. In here I have my template, but let me create a new one. So I'll do my wind. And what we'll see in here is I have different type of databases. So in here, beside the ANSI SQLs, I have a DB2, I have a Microsoft SQL Server, and an Oracle. So I can choose a SQL Server in here. And when I choose a SQL Server, there will be some default settings in here. I'm not going to go through those in this one. It's just all about how we do the reverse engineering in here. But what I have now is I have set up my subject area and I have defined the type of database. And now I can go in and say I want to link up a new relational diagram. So now I have added a relational diagram to my subject area. When I double click and select physical, it will now open an empty physical data model. If I right click on the data model, you'll see that up here I have something called a data source. So I already have a data source in here defined. Let me just open this one so you can see what it is. So this is a data source connection with a server name. The provider, that is the how we connect to the database. There is some connection data in here, and then if we go and look at the catalog here, so let me just see if I can open this one for you. You'll see that this one here is set to connect to the database through the server. So that means even though you have a lot of clients, meaning QualiWare applications up and running here, they will all be communicating to this database through the server. So that will solve some of the network and access rights permissions in there. On the catalog here, if I click this one, it should be able to look up and find all the databases defined on this SQL server. And in here I have my Northwind database. I'll just add a TXT in here and I'll explain to that in a second. Again, there are some default settings that I can define in here. I'll come back to that in a second. But what I have now is I have a relational data diagram. I added a connection to a physical server with a specific database defined. What I can do now is I can go up through my menu and ask the system to do a reverse engineer of this database. It now has looked at the SQL server, and as you can see, it finds a set of tables and the associated schemas. So it can separate between the different schemas as well. And you can select specific tables or just ask the system to import all the tables available in the database. And it'll now start to run through that database and slowly build up all the different content in terms of tables, indexes, attributes, and relationships. So, but here we go. And so let's see here. And now we have all the tables, and we can start to see if we can make this look just a little bit nicer. Now, there's a couple of things that that has happened in here right now. First of all, you have all the tables generated. If I go in and open the tables, you'll see that now we have all the columns defined as well. We have each field with the right data types. The indexes have been imported in here, so if there are multiple indexes, they will all pop up, and you can see those as well. So all the regular type of data model type of information is defined in here. If I go and look at the diagram itself, what we'll see in here is that there are some physical information in here as well, all coming from the database. So besides importing data that is relevant for the data model itself, we are also importing information about the server it comes from, and we're picking up pretty much as much information as we can. So as you can see here, and there's the server version of the SQL Server. If I dig into the database files, we'll see that we can go very deep, and we can even see if we dig far enough the actual files. So this is the file where this particular database is stored in. So this is a lot of information that is not really interesting maybe for a data modeler, but what this can be used for is documentation. It can be used as documentation for where do you have the information residing in your organization, which servers, which physical files actually contains this information. That can be relevant for many reasons. One of them is data security and the ability to identify exactly where information is stored. So if you, again, and I'll come back to this model in a little bit and talk about DDL as well, but I can also take this physical model and I can do conversion the other way. So before I took from the conceptual through the logical to the physical. This time I can take it from the physical and I can move it up to the logical layer. Now it'll start to build a logical data model based on that physical model that I had defined. Now let's just let it generate this one. There we go. Now, one of the things that we often see, and I'm going to come back in a little bit talking about how we can take these data models and link them up against other type of architecture and show how information resides and move around in the organization. But if I go in and look at these data entities that we have here, we have the ability to go in and define classification on these, like what sort of information classification here? Is this open? Is it internal information? Is it restricted? Is it classified? Does it contain personal sensitive data in them, or is it just common personal data, or is it not categorized at all? So this gives me the ability to take my physical databases that are running in the organization, suck them in here as a relational data model, then lift them up to a data entity level and start to add information classification in here. I should mention though that this information classification, if we go in and have a look here, you can add that information classification on the attribute level as well. So you can use this to do some sort of aggregation of data classification. And I'm going to show you some reporting we can do on that as well. So it all depends on what really makes sense and why you are using this. But it is possible to add those type of information to these data models as well. Any questions on anything I have? No?
No, I don't have anything in chat. No, everybody's still here. And, I don't have any questions in chat. If anybody wants to unmute and ask a question, feel free.
All right. As you can see, there are these little green dots on the diagram here on the tables. So these talk about changes. Have any changes been applied to the data model? So right now, if I go in here and I press the generate DDL, what we'll see up here is this system's ability to generate a complete set of DDL to generate this this data structure in a database, in a SQL database. But what we can also do in here is if I go in and I start to change something in here. So let's see here, the address. I want this to be a little longer. I'm going to change it to 80. What you'll see is this little green dot now turned yellow. So if I go back and instead of generate my create DDL, I can create update DDL. And what it'll do now is it'll create the DDL required to apply the changes that I have added in here as well. So it's possible for this system to go in and monitor those changes and use it to maintain these type of data models as well. And it also works the other way. So if I have a data model here where I just deleted a table, if I go in and do the reverse engineer again, it'll go in and find the changes and apply those changes to the data model. So it's possible to maintain this always. Also, it's not just a one-off type of generation of these data models. Yeah. Any questions so far?
I have a question.
Shoot.
I see you're creating tables with entities in them and relations, and so there are foreign keys and other things. But there is also the opportunity to define constraints that are outside of that, outside of referential integrity, etc. And I think that's what I know in my report I had recommended a change to it, but there's something called a complex relation that is there to allow you to do that. When Eduardo demonstrated this to me, he wasn't generating the DDL to implement those constraints, so they still had to be coded by hand. Is that still the case?
I have no idea.
Okay.
Yeah.
Okay, well, maybe.
I'm not even good enough to be able to repeat that question to Eduardo, so I would need that in writing to make sure that
Well,
I get
he'll
it
remember
right.
if you mention it. He'll
Okay.
remember it. Okay.
All right. Great. Cool. Now, what I want to do now is show a little bit on how we can take these logical data models and link them up against our architecture and do different type of analysis on them. So for that purpose, I'm gonna jump into our web front end here. And I'm gonna start with looking at a process model in here. So if I pick any process model, you'll see that we're any process or activity will have a field on them. If you open the dialog, either on the web or inside QLM, there will be an attribute in here called users information. The idea with this attribute in here is the ability to talk about where in the organization, from a process point of view, information is either being created, read, updated, or deleted. So that means if I go in here and click insert, you'll see that all the data entities that you have from your from that data model will be available in here. And I can pick any of these, and I can talk about whether this process has a create, read, update, or delete relationship with this particular set of information. This is very important when you talk about any sort of cybersecurity or information certification like the ISO 27001, where you really need to be able to document where in the organization the different type of people information is either produced or consumed. You will have the same type of attribute on information systems. So if I go and pick up a application architecture model in here. So here I have a set of applications. If I take any of these applications and open the dialog for those, you will see the same type of using information attribute in here. And there we go. We have it here, information. And you'll see that we have the same list of data entities in here and the ability to define whether we have a create, read, update, or delete relationship with these. So again, when you do the insert, you have the data entities here. You could on this just link to the entire subject area. So if you have a subject area representing this IT system and you don't want to go into the lower level of details, you can actually link the subject areas directly up on this level as well. The idea with doing this type of mapping and linking this type of information up is that you can now go use the system to do different type of reporting. So I can ask the system to show me all the processes and what information they are dealing with. So here we have all the processes. Now here I can see the information that each of these are dealing with. But I can also turn this around, and instead of looking at it from a process point of view, I can go into my information architecture here, and I can look at information usage. And what this one will do is it'll create a report for me where I have all the information that I have defined in my repository. I can now see the security classification and privacy level of this information. I can see exactly what data structures these are a part of. So if I want to find out where that account information is, I can click on that data structure and it can show me that data, that underlying data model. And I can also see which processes are using that information. and which IT systems are using this. These tables in here, I hope you remember that you can pivot in here. So if I take my classification and drag up here, change the sort order, I now get all the information that has the classification restricted listed up first. And I can put the privacy level in as the second, and again, change the sort order. And now I suddenly have on the top here all the information that is both restricted and deemed personal, sensitive personal data. And I can now see exactly which of these processes are dealing with these, and the same with the IT systems. So again, this could be the type of analysis that could be important if you need to do cybersecurity type of initiative. It's really important for risk management as well, because there are definitely risks associated with all of these that need to be defined, and then the mitigation setups will have to be defined as well. I talked a little bit before about aggregation as well. So if we take kind of a combination of the process hierarchy that we have in here, and all this information, the classification and privacy level, and I have an example in here of what we call a sensitive data view. And the idea with this view is to find processes, then iterate through the process hierarchy and find out if any of these processes are further elaborated in some sort of workflow diagram or BPMN diagram. And what you'll see out here under IT systems and users information is an aggregation where it lists up all the IT systems and information that will eventually be made available to this process. And what you see out here is the highest level of information classification and privacy level this information has. And that means these processes you have here will be under extra scrutiny when you go through any sort of audit or certification process. So whether it's cybersecurity or your information certification type of initiatives, this is the type of report you would use to justify why you put extra scrutiny on some processes versus others. Yeah. It's very, very quiet. So
I have a question.
People to sleep. Yeah, go.
I have a question. Yeah. It's from Eric, and he asked, can you track social behavior when content is consumed by a user on the example you just demonstrated, the ISO process?
Yeah, there's no, the way the social behavior warehouse works in here, it actually tracks every single object you look at. So it doesn't matter which angle you look at it from, it'll be able to register that and make it part of that behavior analysis the system can do. So yes.
Okay, great. Thank you, Eric. Let me know if there's anything else that you want to ask. Okay, he says fine. Thank you.
The I did a presentation earlier on in one of the user group meetings on risk management. Now, all of this ties into the risk management setup as well. So you can go and ask the system for the risk assessment. So if you have done risk assessment on information, so you can see here that there are different sets of information here that have risks associated with them, and there are even controls in place to mitigate those. All of these are in green, so it all looks fine, but the risk assessment and the risk management setup in here will work on the information dimensions in here, as well as any just the same way as it'll work on any of the other architecture dimensions in the tool. Yeah, I think that was about what I was going to talk about from an information security point of view or information architecture point of view.
Great.